Hi friends, so let's do this problem. Okay, so here the question is find the network function v2 minus v1 for the network. So this is the circuit they showed here. Here you can see that there is, as usual, there is a v1 at the input side, there is v2 at the output side, and here they have already given the value of i2 is equal to 0. Why? Because this mesh is open, that is why this current to this branch will become 0. And here instead of i1 they have given the name ia. Okay, and here you have a dependent source, and you have also have another dependent voltage source. And one interesting thing about this is that you can see here that there is a voltage source in between two nodes, right? We all know what is the name of that. That is, if a voltage source comes between two nodes, then that pair is called as a supernode. So that is what you see here. This is what you're seeing is actually a supernode. So if you see a supernode, then you cannot write the node equations. You should write the supernode equations. That's the only difference. Just like how you write a super mesh equations. A super mesh is when a current source comes between two meshes, right? If a current source comes between two meshes, then that mesh pair is called as a super mesh. In the same way, if a voltage source comes between two nodes, then that two nodes completely, that pair is called as the supernode. So here you can see this is supernode. So what I'm going to do is I'm going to redraw the circuit one more time. Okay, so if I redraw it, I will get this circuit, resistor, this is the same current source, which is 2ia. Here you have a current ia, and here the resistor value is 1 impedance, 1 ohm. V1 is plus and this is minus, and here you have another resistor, here you have another dependent source, plus minus. This is a voltage source, this is 2V1. Okay, usually we are supposed to write the equation for the dependent source also, but here if you look carefully, the dependent source is V1 itself, so there's not much of an equation to write for V1. If it was Vx, if it was 2Vx, so we don't know what is Vx, so you have to look in the circuit and see what is Vx, and then you have to write the equation for Vx. So here it's not like that. Here they have given only 2V1, so V1 we already know what is V1, right? So there's not much of an equation to write there. And here you have a resistor 1, and here you have a current, and this is equal to I2 is equal to 0 plus minus V2. That's it. Basically this is the only equation, right? So this is the only thing. So now what I'm going to do is I'm going to do the most important step, that is marking the nodes. So here I'll start from the right and I move towards the left. Now here you can see this is V2, right? We know this is V2. If this is V2, then this is V2. So therefore if this is V2, then this is also V2, because there is no resistor or capacitor or anything between them. So there is no difference in potential. This entire thing is a single connection. So this is V2, okay? And if this is V2, and what about over here also? If you look over here, this is V1, okay? If this is V1 and this is not V1, why? Because there is a resistor between them. So I will give another name to this. What name should I give? I'll give VA to this, okay? VA. So this is V1, this is VA, and look over here, if this is VA, but this is not VA, why? Because there is a resistor between them. So therefore, again there is a difference in the voltage. So therefore, I will name this point as VB. So this is V2, VB, VA, V1. So these are the voltages, okay? The reason why VB exists is because there is a resistor over here. So therefore this value is not equal to VA. So we have to give another name to it, and that's why I called it as VB, okay? So now we can write the equation. So here one interesting thing about the circuit is that VB and V2 forms a supernode because there is a voltage source between VB and V2. Okay, so first I will write the equation for that voltage source. And the equation is, that is VB minus V2 is equal to 2V1, because if you see over here, the positive terminal is connected to VB, the negative terminal is connected to V2. That is why VB minus V2 is equal to 2V1. Okay, so I got that equation. Now what should I do? Now what I can do is I can write the node equation of this. So now I can begin writing node equations. So this is a supernode. So I can write like that: VB, V2 forms a supernode. Okay, so I will write the supernode equation. Supernode equation means nothing. This entire thing is considered as a single node. That's all. This entire thing, this VB and V2 combined, this entire branch from here to here is a single node. Assume that it's a single node and simply write the equation. That's all. So in that case, this is the only branch over here. This is the only branch over here, and this branch the current is 0. So no need to write the equation for this branch. So you have only these two branches, right? So what is the equation? That is VB minus VA by 1, because the value of the resistor is 1, plus, that's it. This is the only branch over here. What about here? This is the only branch, right? There is no current over here. So this is the only branch. That is V2 minus 0 by 1 equal to 0. That's it. See? So in that case, you get the equation as VB minus VA is equal to V2 minus V2. Sorry. VB minus VA is equal to minus V2. Okay. This is also very interesting. You might need this equation. Okay. And one more thing also. Here you can say that VB is equal to VB minus V2 is equal to 2V1. So therefore I can say that VB is equal to 2V1 plus V2, right? I'll substitute that thing over here. So I will get 2V1 plus V2 minus VA is equal to minus V2. So in that case, I can say that VA is equal to 2V1 plus 2V2. Okay, so I got this equation. So I'm writing these equations because I might need them in the future substitutions. That's why. So now that's it. That's the equation for this node. Now I need to write only the equation for VA. So on the node EA, so applying KCL at node VA, what will I get? I will get here the equation. The current in this branch is called as minus IA. It is minus IA because the current is incoming. And here also this current is also incoming. So it is minus 2IA. Plus, and the current in this branch from VA to VB, it is called as VA minus VB by 1 equal to 0. Okay, I can combine these two. So this will become minus 3IA, and you see here is written VA minus VB. We already know what is VB minus VA. See, VB minus VA is equal to minus V2. So VA minus VB, we can substitute. So this is what I'm talking about. That is always a group substitution. Okay, a group substitution is always better than an individual substitution. So here you can say that I can now simplify this equation. This entire equation can now be simplified. So here you see VB minus VA is minus 2. So therefore what is VA minus VB? VA minus VB is plus V2. So this is plus V2 is equal to 0. Therefore I got V2 is equal to 3IA. That's it. See, I got V2 is equal to 3IA. So now what I'm going to do is, that's it, no? So now I have only one more equation to write. That is the equation for V1, right? So let me write that equation. That is the equation, that is I1 is equal to V1 minus VA. IA, it's not I1, it's IA, right? Its name is IA. So IA is equal to V1 minus VA by, what is the value of the resistor? 1. There. This is the equation. So what is IA? We already know that IA is this one, right? That is V2 by 3. IA is equal to V2 by 3. So I will substitute that as V2 by 3 over here is equal to V1 minus, and what is VA? We found VA also, right? What is VA? 2V1 plus 2V2. So VA is 2V1 plus 2V2. Okay, that's it. So therefore I can say that V2 is equal to 3V1 minus 6V1 minus 6V2. Or I can say that what can I do now? I can bring this 6 over here. So this will become 7V2. So you have 7V2 is equal to, and this is minus 3V1. That's it. So the question is what to find? V2 minus V2 by V1. So therefore V2 by V1 is equal to minus 3 by 7. There. That's it. See? This is how we do the problem. Okay, so now let's do this problem. Okay, as our next problem, and here I want all of you to just pause this video and try to do this problem by yourself. Okay, and then finally after doing this problem, then you can just compare your answer and see if you're getting the right answer or not. Okay, so here in this question again you have a dependent source, which you have a voltage source, so therefore again this will be a supernode. There will be a supernode in this equation, and that's it, there's nothing else. So here you have I1 over here, 1 ohm, here 1 ohm, another 2 ohm. This current source is I1 minus I2. Okay, so we all know what is I1. This is the current I1 over here, and here you have I2. And if this is I2, then you can say that the current over here is 0, right, because this mesh is open. So let's redraw the circuit in its Laplace transform. So you will get a current I1, a resistor 1 minus plus, this is 2IA, and what is IA? IA is the current through this resistor. Okay, that is IA, and the value of the resistor is 1. You have another resistor, and the value of this resistor is 2. Here you have another source dependent, this is current dependent current source, and this is I1 by 2, and then you have another resistor over here, and the value of the resistor is 1, and here the current over here is I2, and here it is marked as V2. Okay, there. So this is the circuit. Okay, I hope I haven't missed anything. Okay, so now let's mark the nodes, right? So if I'm going to mark the nodes, we know that the voltage over here is V2, right? The voltage over here is V2. See, it's V2 over here. So if this is V2, then this is also V2. So this is also V2. Oh, and if this is V2, then this is also V2. See, so which means this entire branch is V2, right? This entire connection that you see as a single node, because there is no resistor or capacitor or anything like that over here. So that's V2, and likewise over, if you look over here, you see this is, I can name this, there's no V1, it's not written over here, so I will mark this as V1. Okay, this is V1. So if this is V1, then this is also V1. So this entire branch is also V1. Okay, and if this is V2 and this is V1, then this is another branch, right? So what name should I give this branch? I can either name it as VA or V3. I'll call this as V3. Okay, there, you can give any name you want. Okay, you can give any name you want. So this is, so therefore this circuit has only 3 nodes, that is V2, V3 and V1. Okay, and another good news is that in between V3 and V1 there is a voltage source, which means this is not a node analysis, this is actually a super node analysis. The circuit becomes more simple, right? This is actually super node analysis, which means this entire branch that you see here, this entire branch is actually a single node. Assume that it is a single node. Okay, and so let's write that, and let's write that equation. That's the equation, the equation for this voltage source. How do you write it? Here this is the positive terminal is connected to V3, the negative terminal is connected to V1. So therefore the equation is V3 minus V1 is equal to 2IA. Okay, that's one equation you got there, right there. Oh, all right. Now, what next do you want to know? Yes, of course you need to express this. So you know what is IA, right? So IA is an unknown variable. So which means you need to write the equation for IA. So how to write the equation for IA? Just simply look what is IA. So I have already told you that IA is actually the resistor, is actually the current through this resistor. IA is the current through this resistor. So and what is the current through this resistor? The current through this resistor is actually V3 minus 0 by 1. V3 minus 0 by 1 is the current through this branch, but this current is actually this current, that is V3 minus 0 by 1, is actually flowing from top to down. It's actually flowing from top to bottom, but IA is flowing from bottom to top, so it is equal to minus IA. That's all. See, very easy. So in that case, you can see over here, right? That means, in other words, V3 is actually equal to minus IA. or IA is equal to minus V3. So in that case, I can substitute that over here. So what will I get? Oh, that's very easy, huh? So V3 minus V1 is equal to, this will become minus 2V3. Minus 2V3, right? This will become minus 2V3. So in that case, I can say that, let me see. So this becomes V1 is equal to, oh, I already got an equation very easily. V1 is equal to 3V3. V1 is equal to 3V3. I got one equation already. This I can use, maybe I can use this, or I can use this, or I can use this, whichever is required. I got 3 equations simultaneously from these 2 equations. Okay, so whichever equations you need to use, you can use depending on the coming equations, coming substitutions. Okay, so I found that equation. Now what else could I write? Now let me start writing the node analysis. Okay, let me start applying the KCL. So first I will apply KCL over here. Okay, I will apply KCL over here. So what is the equation for KCL over here? You can say that the equation starts from this branch right here, right? So the current through this branch is I2. The current through this branch is I2. So it is applying, let me write, applying KCL at node V2, right? This is node V2, okay? So in that case, what is the current through this branch is minus I2, right? It's incoming current minus I2. This is also another incoming current, that is minus I1 by I2. So it's minus I1 by 2. Sorry, this is minus I1 by 2. Plus, and the current through this branch is V2 minus V3 by 2. V2 minus V3 by 2. Okay, is equal to 0. That's it. See, very easy equation. So in that case, I can say that V2 minus V3 by 2 is equal to I2 plus I1 by 2. Okay, can't say, sometimes you might need this equation. Yeah, so that's it, we got this equation, right? Oh, there's also another interesting thing. So what is I2 over here? You can write another equation, right? You can apply KCL over here. You can also apply KCL over here. If you want to apply KCL over here, just simply look at the equation here. You can say that this is I2, right? So therefore the equation over here, if I want to apply KCL over here, okay, so the equation will be, here I2 is outgoing, so it is actually I2 plus, and the current through this branch is V2 minus 0 by 1. Okay, and there is no current through this branch because this is open, so there is no current through this branch. So that's it. So you get this is equal to 0. You got that equation also. So in that case, you got what? V2 is equal to, interesting, V2 is equal to minus I2. Okay, we got that equation, which means I can substitute that equation over here if I want to. So in that case, let me see. So what do you got over here? I get V2 minus V3 is equal to 2I2 plus I1, and like I said, V2 is actually minus I2, right? Or I can say minus I2 minus V3 is equal to 2I2 plus I1, or in other words, I can say that, what can I say, minus V3 is equal to 3I2 plus I1, 3I2 plus I1, or V3 is equal to minus 3I2 minus I1. So this is one equation you got for V3. Okay, all right, so let's keep that equation there. Now I'm going to apply. So where did I apply? Now I applied the KCL at node V2. Next I'm going to apply KCL at node V3, but I cannot simply apply the KCL node V3 because V3 and V1 are super node. So I'll apply the KCL to super node, that is V3 and what is the other one? V1. V3 V1 forms a super node. So therefore, that means just simply consider this as your entire node itself. So you have over here what the name of the consists, you have here is minus I1, then you have over here as plus V1 minus 0 by 1, plus V1 minus 0 by 1. Okay, that's it over here, and over here you have these two branches, that is one is minus IA, right? Or you can call it V3. Let me call this as V3. So this is V3 minus 0 by 1 plus V3 minus 0 by 1. and here it is V3 minus V2 by 2 plus V3 minus V2 by 2 is equal to 0. Okay, so two branches over here, those two terms are over here, two branches over here, and those two terms are over here. Okay, so that's it. So now I am going to do is I'm going to play magic. Here you can see V3 minus V2 by 2, right? This is already given over here. What is V2 minus V3 by 2 is I2. That's what I'm saying. So group substitution. That's why the circuit becomes more simple. So I will write over here as minus I1 plus this is V1 and this is V3. But we all know what is V3, right? Let me write this again. V3 plus V3 minus V2 by 2 is equal to 0. So that is this is, so I can write this as minus I1 plus, and this is V1. So this is V1. Okay, V1 is actually 3V3, right? V1 is actually 3V3. I got this, I can substitute that over here. So this will become 3V3. So 3V3 plus V3 is 4V3. So this is 4V3. So simple. This is plus V3 minus V2 by 2 is equal to 0. And in that case, minus I1 plus, what is V3? We have already found what is V3. This is V3. That is 4 into, and V3 is minus 3I2 minus I1 plus, and here you have V3 minus V2. We already know that V2 minus V3 is I2 plus I1 by 2. So I can write this as minus I2 minus I1 by 2 is equal to 0. So you have this as minus I1 minus 12I2 minus 4I1 minus I2 minus I1 by 2 is equal to 0. Okay, I want to remove this 2. So what I will do is I will divide, I will multiply this entire equation with 2. So I will get minus 2I1 minus 24I2 minus 8I1 minus 2I2 minus I1 is equal to 0. Every term is minus, so I can make every term as plus, right? So this will become 2I1 plus 24I2 plus 8I1 plus 2I2 plus I1 is equal to 0. That's it. So in that case, this is I2, this is also I2, there's no other I2, so 24 plus 2 is 26. Okay, so you get, let me write this, 26I2. And what about I1? This is 2I1, 2 plus 8, 10, 10 plus 1, 11, plus 11I1 is equal to 0. What did they ask us to find? I2 by I1. So therefore 26I2 is equal to minus 11I1. So I2 by I1. So therefore I2 by I1 is equal to minus 11 by 26. This is the answer. Okay, very simple. The steps are basically the same, just the same. Just you start writing. So only thing difference is that just look out for any supernode. If it is supernode also, just like how you have studied the Kirchhoff's current law or this mesh and node analysis in your previous videos, right? In your previous chapters you have learned about node analysis. The same analysis we are applying here. There's no much difference over here. The only thing is that we start with the, in this equation we start writing the equation from the right and we move towards the left, just so that we can save time. And like that, wherever you see these kind of equations, okay, you just keep this in mind or mark it so that you might need this in the coming substitutions. That's all. Always group substitution is always less time consuming. Okay.